So this project started out with purchasing an Amazon Dot. A friend had purchased one, and I liked all the features that he could use to control the Harmony remote. And so I thought, well, that would be kind of cool if I could hack into the Amazon and use it to control a robotic arm or other devices, some servos or whatever. Well, I started looking into how to generate code for this, and it turns out that there's a lot to it. You've got to write your code, submit it to Amazon. They have to authorize it. There's a fee for all that, and then it gets accepted and all this other junk. So I tried using stuff like Blink or ThingySpeak and a bunch of others, and didn't really find anything that really did what I wanted it to do. So I was a little bit puzzled and kind of just benched it for a while until recently. In addition to the Amazon commands and that sort of thing, I was interested in also the Internet of Things. The government has kind of spurred this on, and the public and commercial interest in IoT, Internet of Things, is starting to get very popular and active and that sort of thing. So I wanted to learn more about Wi-Fi and how it communicates and other devices and how they communicate and how to link them to the Arduino and junk like that. So I wound up buying one of these Amazon Dots here locally where I live, used for like $28. They were $30 brand new, like at Christmas, and I wasn't ready to buy it, and I didn't buy it. But I did find a Echo Dot second generation, mine's white, for sale here locally, and I bought it, and I started using it here in the house, my wife and I, and it has all sorts of cool little features, like you can make shopping lists and play music and find out the time and ask questions. Like we'll be watching a movie or looking for a movie to watch, and we'll ask Amazon Alexa, what's the IDBM or IBDM rating on this movie, and it'll tell a little about the movie and then what it's rated and by Rotten Tomatoes and a few other, and so we get kind of an idea. So we've been using it more and more and really kind of like it actually, and so we were going to get rid of it but decided to keep it. And then after I decided to keep it, I thought, well, let's see if I can hook it up to the Arduino somehow. That'd be kind of cool. Well, the Amazon has software that you can download on your iPhone, and I'll talk about that more later. But what I did find was there is the Wi-Fi capability, I should say, of the Arduino is not the greatest. You can buy a Wi-Fi board that you plug into the back, or like I did, I bought an Arduino Wi-Fi board built in, and it doesn't really work quite that well or that easily yet. Maybe there'll be some routines. I wanted to be able to use a program called Blink that allows your Apple iPhone to communicate with buttons and dials and stuff on your iPhone to be trapped, and you can do stuff with it like turn LEDs on. But the Arduino Wi-Fi board doesn't do that. But what does do that and works quite well is this board. It's called a NodeMCU ESP12E Internet Wi-Fi Development Board. It says open source and all this stuff, which is great. And it uses the Arduino IDE, and that's how you program this board. You use the same code as the Arduino. So I was kind of torn. I wanted to just stay towards using just Arduino. But this board here offers so many features, and it's so inexpensive. It was only $8, $9, and I bought it from Amazon. That I was very pleased at how well it worked. It worked great with Blink, for example. It's an app you download, BLYNK, and you can create virtual number pads or dials or stuff on your iPhone. And iPhone, traditionally, you cannot connect to the Arduino. The serial port is locked somehow, and it doesn't work so well. I think Android devices you can work no problem. Like if you want to make a remote control car or something, you can do it. Apple, you can't. So this gave me the first option to use the Apple using Blink to turn LEDs on and control other devices. And you just hook up to these pins here. You can see there's a D7, a D8. There's a number of pins. They all work basically the same. This board is a 3.3 volt or 3 volt, 3.3 volt board. So some 5 volt devices, you got to be careful. They won't work. But the Wi-Fi on this works very well, and it's easy to get to and access. And so I thought, well, okay, I'll get one of these boards, and maybe I can have this board do the Wi-Fi communication and then connect it using a serial-to-serial communication to the Arduino Uno. And that's basically what I did. So the way it works right now is I have the Amazon Dot, and I say a command like turn light 1 on. And light 1 is the device ID. It's the name of the device. I can call it something else in the software. I can call it turn tabletop on, or turn tabletop off, or turn car on, or turn car off, or whatever you want to call it. Turn palm tree on, or turn palm tree off. The ID name doesn't matter. In this case, I used what the default was, which was light 1, light 2, and I've created up to 25 lights. All of them I can access directly, just saying turn light 1 on, turn light 12 on, turn light 25 on, or off. And they all worked perfectly, each of the devices. So I think the software that I load onto here, which is called FOMO ESP, it's a library, allows you to create devices using unique device names, and then you can address those device names using the Amazon Alexa Dot. And this will trap it, and depending on what you code, send a signal out D6 or D7 or D1 pin to light an LED or whatever you want it to do. In my case, I had it trap a device name like turn light 1 on. It would trap it in a case statement and then send a capital letter A serially to the Arduino. But there's a problem. You can't just send you can't just connect pin D7 to the Arduino serial pin RX in, because this is 3 volts and the Arduino's 5 and it won't work. That's where I bought this, which is a 2-channel like voltage converter. It goes from, here's channel 1 up here. Let's see if I can make this bigger. Here's channel 1 up here, channel 2 down here. This is low voltage ground, high voltage ground. And then you go from low voltage TX1 to high voltage TX0, I guess is what it's numbered here. And from the NodeMCU module, I have it come in from transmitting the TX to here. And then I have the TX out of this going into the RX of the Arduino. And that's how it transfers the capital A low voltage to the capital A high voltage of the Arduino. And the Arduino then uses a case statement to trap the letter A, or if it's a letter B, or whatever letter I assign, and then acts upon that accordingly. And so that way I can control other devices using the Arduino, which has much better pinouts and control of peripheral devices than the NodeMCU. I just use the NodeMCU as a Wi-Fi module, kind of, to trap and send characters over to the Arduino to make it do what I want it to do. So that being said, I would like to, here's some of the code, but I wanted to show you this first. This is the Alexa, Amazon Alexa app that you download onto your iPhone or Android phone. It doesn't cost anything. Basically you set it, when you write the code, it generates this. Under Smart Home option, you go over here to these little bars, and it'll come up with just your home screen, which is this down here on your phone. But then you click Smart Home, and then you click, and it's all under this menu over here. You click Smart Home, and then you click Devices, and then the code that you write on the NodeMCU will generate these devices: Light 1, Light 2, Light 3, Light 4. You can call it anything you want. I just called it Light 1, 2, 3, 4, just so you know. And these are actual devices, and I think it kind of considers the device a light switch of some sort, or light module, because you have to say turn device name on or turn device name off. You don't have a choice. Just saying the device name like Light 4 won't work. So that was kind of a negative. So with this project, there's a couple things I wanted to do. I wanted to use the Amazon Alexa with the Arduino Uno. I wanted to use a speech recognition module that I have, the EasyVR3, to say a command to the Alexa to get the project to do something, act on a command. I also wanted to, lastly, work with the IoT or Wi-Fi module to communicate with my local network and to communicate with the Alexa to get it to work together. And you can see Alexa is actually active here. So in doing that, that's what the meaning of this project was. And it's not a very complex programming-wise project, but it does implement several components that are technically interesting. So to start out, I tried to find a module for my Uno, Arduino Uno, to connect to the Wi-Fi, and that wasn't so easy. You can buy a board that you plug in, or you can buy the Arduino Wi-Fi board, and that's actually what I bought, was the Arduino Uno Wi-Fi board, and that did not connect to the internet so well. So I kind of scrapped that idea and found this module, which is a NodeMCU development board. It connects to the internet very well, and it also uses the Arduino IDE for programming. So I liked all that, and after looking on the internet, I found a program, a library called FOMO ESP, which allows you to connect the Amazon Alexa to, it keeps coming on, to the Wi-Fi module. So that actually worked out really well. And so that's what I wound up using. So basically the way it works is the Amazon Dot, I'll say instead of, and connects through your home Wi-Fi, which is, you know, say another room, to the NodeMCU, which is also connected to your home network, and they communicate. And the software that you upload to the NodeMCU allows you to generate devices, and the devices that are for the Amazon Dot are basically light switches. So every time you give a command, you have to say, turn light 1 on, turn light 2 on, turn light 3 off. You don't have to say light, but you do have to say the word turn, and you do have to say on or off. So theoretically, it's always going to be kind of like a switch. Even if you say something like turn palm tree off, you know, it doesn't make sense, but you could do that. And you have quite a few devices that you can create. I've created about 25 or 30 unique devices, and they've all worked quite well. So you could have quite a few devices that you run off of or you control with this program, with this project. So basically, you create you code a device name, and that device name gets created, and the Amazon Dot can access that device name every time you use a voice command. And so that command gets created, it gets sent Wi-Fi, and then the NodeMCU receives that Wi-Fi device command and parses the command into a device name and a device ID. And then I trap the device ID, not the name. And depending on the device ID number, it's just a number from 0 to how many devices, 1 minus the number of devices you have. That number then is converted into a character, a capital A, a capital B. It can be any character, but I use the alphabet. So, and then I send that character from this port here. I transmit it to the Arduino Uno. Well, there's a little bit of an issue there. The NodeMCU is 3.3 volts, and the Arduino input pin is 5 volts. And you don't want to connect a 5-volt device to a 3.3 device. You can burn it up. So you need a voltage converter. And this little voltage converter converts it from one side here, it converts from 3.3 up to 5 volts. And so I take the pin out, which is the transmit pin I've declared in my code from the NodeMCU. I transmit it to the low voltage of the voltage converter, and then on the opposite side, the high voltage pin gets transmitted to the receive end of the Arduino Uno. And the Arduino Uno, with the EasyVR module plugged into it, converts that, uses a case statement to take that character and then say verbally another command to the Amazon Dot. And then the cycle just repeats. It says a new command. It gets transmitted Wi-Fi. The NodeMCU reads in that Wi-Fi command or device ID, sends out a different character through the voltage converter into the Arduino. The Arduino takes that, traps it in a case statement, and then says another different command through the speaker to the Amazon Dot. And then the cycle just keeps going and going. So to get this started, you need to give an initial command. And that command is real simple. You just say, turn light 1 on. And that's how it gets started. So let's activate. Alexa, turn light 1 on.
Alexa, turn light 1 on.
Okay.
Just what do you think you're doing, Dave? Alexa, turn light 2 on.
Okay.
Your dog was a mongoose. Alexa, turn light 1 on.
Okay.
Just what do you think you're doing, Dave? Alexa, turn light 2 on.
Okay.
Your dog was a mongoose.
So these are the two devices. The one on the left on COM5 is the NodeMCU. The panel on the right for COM7 is the Arduino Uno that receives the character. So initially, the NodeMCU will start sending a letter. Here it started out with B. It will transmit that over to the Uno. And once the Uno receives the B, it says a command, Alexa, turn light 1 on. And that's where you see this command here. So the NodeMCU received this command, it processes it through a case statement, and then sends an A. And then here's the A right here received by the Arduino Uno. It processes the A, and in the case statement here, it requests a B, and it says, Alexa, turn light 2 on. And then that's what you see down here, turning light 2 on. And it starts sending a B. And it'll just oscillate between A and B, back and forth. I only have 2 devices named, but you could have, I've had up to 25 to 35 different devices, and it had no problem. It didn't make any issues at all. So here's the list. It keeps sending. Here it sends a bunch of A's because I was talking during this time. But down here it winds up starting back on the right cycle. Once I'm not speaking, it goes light 2 on, starts sending a B. And I guess here's the B. And then it says light 1 on, starts sending an A right here. And then I started talking some more. So once you interrupt that Alexa, and if it doesn't process it, it'll continue to send the same character over and over and over until it actually gets the correct device name in order to trigger a new state. Here's light 2, light 1. So that's how that works. This block of information at the beginning. This program is one of 2 programs that connects the Amazon Alexa using Wi-Fi to a NodeMCU development board, or NDB. The NDB uses the code unique devices to trap unique characters and TX them, transmit them to the Arduino Uno for processing. A voltage converter is necessary to upconvert the NDB's 3-volt pinout to the 5-volt Arduino Uno's pin voltage. Depending on the character sent, that's not sent, it should be sent, to the Arduino Uno, the EasyVR3 module will say a verbal Alexa command. And so, for example, Alexa, turn light 1 on. The device light 1 is defined when the NDB logs into and connects the local Wi-Fi network and the Amazon Alexa. A device list can be displayed using the Amazon Alexa phone app, which I showed earlier. Once a verbal command, got to edit this on the fly, is given, the Alexa Wi-Fi's the command including the device ID to the NDB to start the entire process over. So basically, the VR3 will speak the command. It'll say, Alexa, turn light 1 on. Alexa, turn light 2 on. That's actually what the VR3 will wind up doing once you get it going. You got to give it one command at the beginning to start, and then it just cycles itself. 2 programs are required: the generated EasyVR audio sketch and the final NodeMCU TX sketch. Those I will make available for everyone. Please watch my videos. So here I also include all my notes that I use to figure this out. I encourage you to click on them and watch them. A lot of them are YouTube, and they're quite good. A little bit I have here of Blink. I don't remember where I saw it, but up somewhere around here I have some Blink information also. Blink is a different app, but I encourage you to play with Blink also. You have to generate you download it on your phone, you generate a key, and then you put that key into your program, and that allows it to communicate, in this case with the NodeMCU, because the Wi-Fi on the Arduino does not connect and hold a connection very well. In fact, doesn't really do it too much at all. So this is one of the code I have up here. I got from one of the websites. The FOMO ESP is really the library you need. That's what this is right here. Here I have software serial required for software serial communication. Here's the Arduino H. The ESP8266 Wi-Fi is required for the NodeMCU Wi-Fi communication. This library, and then the FOMO ESP, this library is that creates the Amazon Alexa device IDs and connects to the Alexa. That's what makes this all work. And then the credentials H was a separate H file that you had to edit to put your password and Wi-Fi in. I didn't do that. This was hard-coded before this was removed. It contained the SSID and password. I just put the 3 lines of code right here. So I got rid of that file. I didn't want to have that lying around. So whenever you run the program, you've got to enter your SSID. It could be whatever the name of your router is. I don't know what some router names are. Maybe the AT&T 135, or if you have Charter, whatever maybe, or Comcast or Netgear, whatever one you have, you put the name here, whatever you call it, and then the password to log into it. Next, I declared my serial with RX pins to create the software serial entity. This creates a FOMO entity. You only need really one, far as I know, to really connect to the internet, or to connect to the Alexa. Here, this is the handshaking required to connect the NodeMCU device board to the Amazon Alexa. I did not change any of this. I just kept it. It was kind of small, so why not keep it? Just goes through this, and then it says connecting, and then there's ... It prints some dots, and once it's connected, it says connected and gives you the stream right here, a little IP address and some other little information. You could take that out if you don't want to see that. So down here, I initialize all the serial ports that I'm using. I didn't use this one. I started to install it, and I left it in because I might use it in the future. Basically, on the NodeMCU, use serial 1. That works better than my serial. I started to try to use software serial with it. It wasn't necessary. It's got serial 1, serial 2, and I think serial 3, and you just address them accordingly. And there is a pinout that you can download. It'll show you what all the pinouts are, and it has the serial ports labeled in the pinout. You can just do a Google search on NodeMCU pinout. It'll come up. A development board. You want to do the NodeMCU development board. There's actually just a NodeMCU little tiny module. Don't do that one. Buy the development board. It's well worth the $8. So here I set up the serial ports, and here I initialize the Wi-Fi setup. This was all in the code already that I downloaded. You can look at the website up above that I listed. Here's the FOMO device ID setup. Here you can see I have light 1, light 3. This is the device name. And it is, since it's the first one, it is device ID 0. This is light 4 or device name 4, but the device ID is 3. So it goes from 0 to 3, just like an array. So here you have your device ID set up. You can call it anything you want, but you're going to have to say turn device name on or turn device name off. You can't get around that. Then it comes down to here, and this is where it does all the FOMO connection with the Alexa, and it takes the command in, and then it processes it on message, then it does it, and so that's where you have to do that. Now, one thing I do have right here is you use the device ID as a control code, must store the device ID to use in loop. You can't address this device ID down here in the loop, anywhere down here in the loop. It'll say invalid or device ID is not declared. So I declare hold device ID up here at the top, right here, as an int, and then I use it to pass this information to my program down here, because I do trap for the device ID, hold ID right here. So let's come down here to the loop. And this is some information that came with the code, so I'm not sure how accurate it is, but it seems to be pretty good. It's fine. Here's a handle. I'm not sure how that really works. I guess that is some sort of communication, but it is necessary, so I would keep it. It prints out some of the NodeMCU status. And then here's where I actually do my trapping. Check if the device is light 1. If it is, then send an A to the Arduino Uno. If hold device ID is 0, meaning if I said turn light 1 on, then I want to send, I print out sending an A, and I serial 1 print an A. And that actually sends the A out to the voltage converter, and the voltage converter sends it to the Arduino. Check if the device is light 2. If it is, then send a B to the Arduino. I check to see if hold device is 1. And I send sending B, and then I send the B, and I wait a little bit for things to kind of fall through. Because this will send stuff so quickly that the Arduino can't keep up. Because it actually has to take it in, read it, flush the buffer, do some stuff. It's time consuming, so I said might as well slow it down a little bit. And then that's it. That's all this code does. There is nothing else. That's all you need for the NodeMCU to read a command from Amazon Alexa and send a character to the Arduino. So let's look at the Arduino code. Now the Arduino code is a little bit more in-depth. I have the same header up here. I should get rid of this because I have it twice. It has the code for the VR3 voice synthesis. I wanted to read a command in, say something kind of clever, and then instruct Alexa to send another code. And that's all I have it do is send back and forth. So here are my same notes. You can look through what you want to see. Again, software serial, set up serial communication. This is the EasyVR3 detection debug code generated by the EasyVR Commander software. When you run the Commander software, there's a button that you press that will generate a template. And in that template, you put your code, and you can delete lines of code if you want. So it created all of this code. And sometimes I go through and remove it. Sometimes I don't. This time I really didn't. I might go back through and delete some of this. But if you're doing it for the first time, you might want to leave it in just to get your thing working and then go back and delete out the stuff you know don't use. So there's one on here, something for a duo. Here's a 0 for 0 programming port. Like I could remove this. Shield jumper on HW for 0 use programming port. Well, I'm not using programming ports, so get rid of that. Or port monitor, or a lot of this nonsense. Here's a Leonardo or Due. I'm not using it. You could delete that too. I just didn't delete it yet, so yeah, I'll do that later. Here's the EasyVR library you need for the VR module. Here it sets up an EasyVR entity. Software serial I will need because I'm not using the serial port on the Arduino. I'm using port 2. Typically 0 and 1 are RxTX. I'm using 2 and 3. I use that because if I use 0 and 1 and you try to upload a program to the Arduino, you can't. You got to keep disconnecting the TX line or RX line. It won't load. It'll just sit there and hang. So I did software serial to different ports. Here are some variables. I did not use the group or predefined word sets in the program, but I kept for future use. There are groups and word sets that you can declare that come with the module, the EasyVR3 module, or you can write your own, add your own, and access them this way. I took that out, but I did leave this in because I might want to use it in the future. The declaration up above, I did not keep. So coming into the setup, here's the EasyVR3 bridge detection code generated by the VR Commander software. It tries to detect it. There's a bridge jump here so that it can continue to search for it. It looks for some sort of bridge. I actually run only this code here. I could delete everything else. I did not use a bridge. I'm not really sure what a bridge is. I didn't need it at this point. So it just runs normally. I could just keep this case statement and just run it and be done. But there's other bridge ports here. I don't know how your setup is, but you might want to keep it in just in case. Here it initializes the EasyVR, make sure it finds it. If it doesn't detect it, it gives you error code and blows out. Otherwise, it gives you the version and it's found. Here it does an LED low, it lights up an LED. Again, this is more detection for what version of the software it's loaded or firmware is loaded. So I left all that in. I think a lot of that can be whittled away if you're willing to deal with trying to figure out what the problem is yourself, or if you need space and you're running out of memory, you can get rid of it. It was nice that they used the F option here to load this string into, I think it's SRAM as opposed to regular RAM, so that saves you a little bit, but it's not very much. This says it speeds up replies, and that's okay. This is set up the timeout, and then the language. This is all preset, so I didn't. And then it gives you the group. I'm not even using group, but starts out with the trigger. You can start out with whatever group you want. Again, I didn't use that. Here's where I start right here. I set the pin mode as input, the pin 3 as output. This is the RX and TX. Serial begin, and then my serial 9600. And then we go into the loop, and the loop is pretty straightforward. I flush my serial to make sure there's no weird characters. I wait a little bit of time to let that happen. And then while my serial is greater than 0, I read a character, and then I print that character out. Then I come down, once I've got that character right here, I say C is equal to my serial read. Then it comes down to the switch statement here. And based on the character, whether it's a capital A or capital B, it'll do each case statement. So if it is an A, it'll play the sound Alexa. That's what sound number 2 is in my commands that I created. And then it will then say play sound 4, which is turn light 2 on. So if I get an A, I want the speaker to say, Alexa, turn light 2 on. And then it goes and turns light 2 on, which will then send a B. Because light 2 is connected to B, light 1 is connected to A. So if I get an A, I want a B next. So I say turn light 2 on, and I wait a little bit, and then I make a funny sound here. I just say a statement, your dog was a mongoose. And then the whole process starts over. It falls through. That's the end of the program. It comes back up here. It flushes it. It comes in. And this, sometimes I do this as a while statement. While my serial dot available is less than 1, you can wait. And then once you read the character, then it goes on. So here I have an if statement. It worked with the if statement, so I just kept the if statement. But there's different ways to set up this command in order to read this one character. Basically, this whole if statement is the whole case statement. So if there's nothing else in my loop except for a flush. So I flush, I wait a little bit, so hopefully one character comes in. If my serial has greater than no characters, then it sets it. So it might loop a couple times before it catches one character. It doesn't matter because the NodeMCU is sending an A over, A after A after A after A. And it'll keep sending A's over even while we're processing this until it gets until the VR3 says a command, Alexa turn light 2 on or Alexa turn light 1 on. And then it'll start sending over B's. It'll keep sending over B's, and this will keep looping through this around this if statement until you flush it. And then there's a delay, and it captures one or a couple characters, more than 0 characters in the serial buffer. And then, it'll say, my serial is greater than 0, read one character, okay, print it, process it, come back up, flush it, and then go, and then by then the NodeMCU has sent a B over. So the NodeMCU is really just flooding this with A's and B's. And I could possibly see that be, you might have some sort of timing issues if you start to get more devices where you have a larger and larger case statement and it takes longer to process. I will do that. I probably will wind up doing that in the future. I will try to code like maybe 50 devices or 50 LEDs or something to turn on and off through voice, just to see what happens when you really maximize this. But for right now, for just 2 commands, it works great. All I really wanted to do was show how to use an Alexa, a Wi-Fi, and the VR3 speech synthesizer board to control the Alexa as an example, and that's what I did at the beginning of this video. So I hope that kind of helps. Again, I want to do more projects with Wi-Fi and the Alexa, and I will put more out there. I'm also interested in trying to connect 2.4 gigahertz quadcopters or robotic devices using all of this too, using the Arduino and that sort of thing. So that's going to be one of my next projects also, so stay tuned for that. I hope you find this informative, and please comment, subscribe would be great. I don't respond to email, I just don't really have the time. I appreciate you asking questions. Maybe someone else in the forum can respond or read the forum and to see if someone else has already responded with your question. I do show how to use the VR3 Commander and grammar building program, the QS5, I think it's called, in another video, in my other VR3, EasyVR3 video. I did use for the voice, naturally speaking or something like that, some sort of voice to text or text to voice program. It's more consistent and easier to control than my voice when I'm talking, and it doesn't sound weird to hear myself talking. I can set it up with a male voice or female voice. But other than that, I hope you like it, and I hope you like this video, and I hope it's helpful. Take care.